All right, so in this video, we're going to go over three basic equations and determine symmetry, okay? Symmetry with respect to the x-axis, to the y-axis, or to the origin, okay? And we can use the concept of symmetry to make graphing easier for us, okay? And in subsequent sections, we're going to be graphing different functions, and symmetry is going to make that process easier for us, okay? Now, previously in other classes, geometry, algebra 2, whatever, you should have talked about symmetry, okay? When you're graphing parabolas, for example, you would have used the axis of symmetry to help you graph parabolas more easily, okay? So we're going to do, again, some basic equations here, and I'll show you the process of how to determine what type of symmetry an equation might have, okay? So we're going to deal with x equals y squared. We're going to have y equals x squared, and we're going to deal with y equals x cubed, okay? Now, you got to remember, if an equation is symmetric with respect to the x-axis, then it can't be a function, okay, because it would fail the vertical line test, okay? These others, if you are symmetric with respect to the y-axis, you could be a function. If you are symmetric with respect to the origin, you could be a function. But if an equation is symmetric with respect to the x-axis, it's definitely not a function, okay? And again, that should, be a review from stuff you previously learned, okay? So we're going to start with x-axis symmetry here, and all you have to do, you're going to replace y with negative y, and then when you go through the simplifying process, if you end up with the same equation that you started with, then you're going to have that symmetry, okay? In this case, x-axis symmetry. All right, so the evidence here to prove that this is symmetric with respect to the x-axis is we're going to plug in negative y where the y was. We're going to use order of operations to simplify here. So when we square negative y, we get x equals y squared, okay? So notice these two equations match, okay? And that's why this matching is why this equation is symmetric with respect to the x-axis, okay? I'll show you the graph of this in just a second. But let's verify that this equation does not have y-axis symmetry or origin symmetry, doing the same thing we did here, okay? So with y-axis symmetry, we're going to replace x with negative x, okay? So where there was an x, I'm going to replace that with negative x. Now notice there's no simplifying that can be done here, okay? Notice that this equation doesn't match that equation, so this equation will not have y-axis symmetry, okay? And this proves that this equation is not the same as the one we started with, okay? With origin symmetry, we're going to do both. We're going to replace x with negative x, and we're going to replace y with negative y, okay? So let's check the origin symmetry for this equation and see what happens. So we're going to replace x with negative x, we're going to replace y with negative y, and then we're going to simplify. So on the left side, I'm left with negative x. On the right side, I'm left with y squared. Again, notice this does not match the equation I started with, so this equation will not have origin symmetry. Okay? Now, let's give you some visual proof real quick. If you were to graph this equation, again, this is not a function because it has x-axis symmetry, it would look like this, okay? And you can see that for every point below the x-axis here, there's a mirror image point above the x-axis, okay? So if I know one ordered pair, I'm able to use symmetry to find the other ordered pair that would be below the x-axis, okay? And we'll talk more about using symmetry to graph in a subsequent video, okay? And again, you can see visually that this equation, this graph, has x-axis symmetry. All right, now let's do some symmetry with respect to the y-axis. So I'm already telling you this equation, this is a function, has y-axis symmetry. So let's just go through that real quick, and we'll verify that we don't have x-axis symmetry. So let's replace y with negative y. Again, we're checking x-axis symmetry. So we're going to replace y with negative y. Okay, there's no simplifying that can be done. Notice that doesn't match. So there's no x-axis symmetry. Okay, checking origin symmetry, we're going to replace y with negative y and x with negative x. When we simplify, the left side stays the same. the right side becomes x squared. Notice again, that doesn't match what I started with, so no origin symmetry there. Okay? All right, so evidence that there is y-axis symmetry here. We're going to replace x with negative x. We're going to simplify, and notice that we end up with the same equation we started with. Okay? So this function, this equation, will have y-axis symmetry. And here's graphical representation of that. Okay, you can see again, this is kind of my axis of symmetry. This is the y-axis. If there's a point on the right side of the y-axis, there has to be a mirror image point that's equidistant from that y-axis on the other side. Okay, where y is 2, I've got an x value here, and I've got the opposite x value here. Okay, so that's y-axis symmetry. And then I'm telling you this one has origin symmetry, so let's check the other two. X-axis, remember, I'm going to replace y with negative y. No simplifying to be done here, okay? And that does not match. Check y-axis symmetry, replace x with negative x. When you cube a negative here, you still have a negative. Notice that doesn't match either, so no y-axis symmetry, okay? Again, I told you this one had origin symmetry, and let's replace x with negative x, y with negative y, okay? That gives me negative y equals negative x cubed, and if I divide both sides by -1, I get y equals x cubed, okay? Which matches the equation I started with. So that's why this function, this equation, has origin symmetry, all right? Let's look at the visual representation of this, and you can see the origin is my axis of symmetry. So up here I've got the point 1, 1. That's on the graph here. Well, if I change x to negative x and y to negative y, then I should have a symmetrical point here with respect to the origin at -1, -1, and so on, okay? So that's how we determine symmetry in 3 really basic examples. The more complicated the equations are, the tougher this process gets, okay? But this is just a quick introduction. We'll get deeper into this in the next unit.